Maybe you're curious about the math that occurs when someone mines for Bitcoin. For today's video, we will be going to talk about cryptographic hashing function. Explained. Let's get started. What is a cryptographic hashing function? Consider a cryptographic hashing algorithm to be a magical black box into which you put something and it pops something out. A hashing function is simply a system that accepts input and generates a hash. So we'll get into what a hash is in a moment. But for now, just know that we need it. There's a lot of math going on inside this so-called magical black box right now. However, you essentially give it something, and it then poos. Bitcoin employs the SHA-256 hashing function in this example. There are numerous functions, but SHA stands for Secure Hashing Algorithm, and 256 refers to the number of zeros and ones in whatever it outputs. So whether you put in your name or you put in the entire dictionary, what it pops out will always be 256 ones and zeros. Now that our computers are extremely intelligent, they convert these binary ones and zeros to actual letters and numbers, which is equivalent to 64 numbers and letters. There are many different hashing functions, but Bitcoin uses SHA-256, which we will focus on in this video. 5 main things about a hashing function. Let's get started. Essentially, you need to understand 5 key aspects of a hashing function. Number 1. If you give it the same input, it always produces the same output. Then it would output this, but repeating the process would result in the same seemingly random numbers and letters. They will, however, be identical. These numbers and letters are now known as the hash, and as I previously stated, it's actually a bunch of ones and zeros that we convert into numbers and letters, so we can look at it more easily and copy and paste it. Number 2. No matter how much data you feed it, it always produces the same size output. If you give it an A, it will return 64 numbers and letters. If you enter double A, it will return 64 numbers and letters. If you give it triple A, it will return 64 numbers and letters. If you give it the entire encyclopedia, it will return 64 numbers and letters to you. Finally, if you enter my social security number, it will still return 64 numbers and letters. The block box is magical in the sense that it will always output 64 numbers and letters whether you give it a letter or a million letters. Number 3. It is simple to compute. So this would be an excellent location to demonstrate exactly what's going on inside this hashing black box. However, it is very technical, and not everyone who watches this video needs to fully comprehend how it works. If you do, here's an introduction. It first converts your message to binary, then adds a single one, then zeros until it reaches a multiple of 512 ones and zeros. Then it appears as 64 bits, and this is where most people will have to look up what initializing hash value means. All you need to know is that it does a lot of math with ones and zeros. Computers are extremely good at math, which brings us to our third point. It must be simple to compute. In fact, most computers can perform a few millions of these per second. Number 4. It is impossible to reverse or predict the hash. So if you do the SHA-256 and subscribe to our channel, you'll get this as the result. However, if you do, please subscribe to our channel because you will receive something completely different. Finally, if you changed it just a little bit, we'll just add an exclamation point. You get this as the output. There's a reason why we want a small change in the message to drastically alter the hash because it could be predictable otherwise. This would jeopardize the security of the entire hashing algorithm. Number 5. Finding two hashes with the same input is impossible. In fact, there are currently no known two inputs that produce the same output in SHA-256. An MD5, on the other hand, is a different hashing function with a different magical black box and does different math. For example, this input and this input both yield this. However, there aren't many of these collisions discovered, and SHA-256 is far more powerful than MD5. So people have been mining for years, creating billions upon billions of SHA-256 hashes, and no collision has been discovered. If you're lucky, you'll find it yourself, and you'll almost certainly win an award. However, you should be aware that two inputs are uncommon, otherwise never generate the same hash. What does it have to do with crypto? What is a cryptographic hashing function, and what does it have to do with crypto or cryptocurrencies? It all comes down to something called proof of work, which is the exact method we use to mine Bitcoin. Essentially, here's what we are doing. First and foremost, we are compiling a list of all the transactions that people want to be added to the blockchain. Second, we add a random set of numbers and letters to that transaction list. Finally, we calculate the SHA-256 of that until we get an output with a specific number of zeros. So in this case, we'll figure out how to subscribe with 7 zeros. As previously stated, we cannot predict what we will need to add to it, so we'll have to guess and see. Let's start with 1 and work our way up. So we start with subscribe 1, and get this. It does not end with a 0, but with a 6. Then, using some simple Python code, we can keep adding new numbers to the end of the hash until we get a 0. So, as we conclude this video, we hope you learned something useful. And if you enjoyed this video, please press the like button, turn on the notification bell, and subscribe to Metaverse for more videos like this. Thank you for stopping by to watch. See you in our next video.